Let me write up some other examples of some exponential functions. Take, for example, if we had f of x is equal to 2 to the x plus 3. Okay, this is an exponential function. We got the independent variable up here is in the exponent, which is x, and the base is just a number. So I can actually break this up into 2 raised to the x times 2 to the third. 2 to the third power. Okay, these are properties of the exponents here, and of course we can bring this out. 2 to the third power is 8 times 2 to the x, and there's times when we want to do this. Now the graph, I'm just going to kind of sketch what the graph looks like out here of this. Okay, we looked at this graph here just a little while ago, and it's similar. It's just about the same. It's going to be the same graph. Now remember, if we throw a negative out into the front of this thing, toss a negative out front, what's going to happen? It's going to cause this graph to do this. Okay, going to cause the graph to do that. So remember, we throw negatives out front. This is what we get. Now what if we had f of x is equal to a half raised to the x? Now I think I graphed this out earlier. We're going to get a graph. How about I just do this in a different color? That's going to decrease. Okay, that's known as exponential decay. And what's happening here is you can by the properties of exponents we can do this. Okay, we can drop the parentheses. It'd be 1 raised to the x, 2 raised to the x. Of course, 1 raised to the x is always just going to be 1, and then this is 2 raised to the x. Well, let's focus on what's happening down here. When I plug in, for example, 2 raised to the 1, you get 2. 2 raised to the 2, you get 4. 2 to the third, you get 8. Well, if we looked at this, this would be, for example, 1/2, 1/4, 1/8. So what's happening here? This number's getting smaller and smaller and smaller. That's the reason the graph is decreasing like it is. As x gets larger and larger, right, f of x is getting smaller and smaller. And as you go out further and further on the x-axis, right, this blue line is going to get closer and closer to the x-axis but never touch it. It will never touch it. Now what happens when we what happens to this graph when we throw a negative out in front of it? So I'm just going to keep it all in parentheses here. Right, we'll call this one g of x. So when we throw a negative, now I'm going to go ahead and redraw our graph here. And then I'm going to draw this one here. This one's in blue. How's that? Should have made it green, I guess. So what happens when we throw a negative out in front? It flips the graph, right? It flips it because it's going to make every one of these numbers negative. Okay, if this were, for example, 1/4, this then becomes -1/4. Okay, so throwing negatives out in front causes the graph to flip about the x-axis.